So, welcome to another episode of Beta Talker. Today, I'm doing one of my heat pump ready episodes. So, obviously, the views that you're going to hear are the views of my guests, and they're not the views of the government or any department within the government. So, I'd like to welcome to the show. We have Christopher Taylor from Vital Energy. We have Richard Barwick from RJ Barwick. Is that right, Richard? Have I got that? That's what you're.
RJ Barwick Limited. Yeah, that's
Yeah.
correct.
And we also then have Russell Murchie from and Nusku. Is that right?
Nusku. That's correct, yeah.
I should know because I was chatting to your Andy McKay quite quite a lot the other day on LinkedIn because he's the other he's one of the
He's co-founder, yes.
So, gentlemen, we're all here to talk about your projects that you've got going on the heat pump ready programs. So, I'll start with you, Russell. Just sort of give us a brief description of what your project is, because this is all around sort of some really clever innovation, isn't it?
Yeah, absolutely. So we're looking at how we can basically remove barriers to adoption for heat pumps, but the particular part for this project is for a distressed purchase. So how can we quickly replace a gas combi boiler with a heat pump package? Um, so all packaged in one unit that sits outside the home, doesn't require lots of installation time and effort and cost.
That's brilliant and succinct. Thank you for that. And Chris, I think, are you doing something similar? You've got like a.
Yeah, it's kind of similar in that we're doing an externally sited unit. So the idea again is it simplifies the installation process. So the unit's standardized. You've got a heat pump in it and a high temperature a high temperature heat pump and a thermal store in there. The idea is it can be prefabricated, done at scale. Um, because it's standardized, the idea is if you've got a few of these units about, it makes it easier to maintain. You can share spares around and things like that. Our unit's a little bit larger in that it's designed to do a number of homes. So heat as a service is really the thing that we're going for. Again, the idea that removes some of the barriers to entry of customers to connect. And inherently, we're trying to look at both technical improvements, so improving the technical efficiency and also improving the commercial efficiency through flexible operation. And the target for that initially is mid and high rise buildings, or put one of these units at the bottom of those buildings, and again can deploy that quite quickly. But equally, it could be applicable to sort of a housing estate or something like that, sort of 50 odd homes.
And it's air source, is it?
Yes, it's air source, albeit down the road there'll be water source iterations, no doubt.
Richard, you do something quite different to these two projects, I think, don't you?
Yeah. Thanks, Nathan. So, hi everyone. Yeah, so RJ Barwick is a specialist retrofit project manager. So we focus on the whole house retrofit solutions with social landlords. So the heat pump is just one part of the overall solution. We've on this heat pump ready project, we've been working with four social landlords. That's three housing associations and one local authority. And the ultimate destination is to retrofit 20 properties. And that's two pilots of 10, 10 in Wolverhampton and 10 in Snodland in Kent. And the Wolverhampton would 10 would be with Wolverhampton Homes, social landlord there. And in Kent, it's with Clarion Housing Group, who are a large social landlord. And so we're working on sort of whole house archetypal solutions, primarily those sort of interwar and post-war archetypes built, in many hundreds of thousands around the country in that sort of 50s and 60s period when we were probably building more houses, in fact, than we ever have since. But unfortunately, many of them are now, having been built for a 30 or 40-year life, very inefficient and, need some attention, not just for the maintenance and, good order, decent homes, but for the thermal and heat demand reduction.
So this is a very archetype-led approach. This is very specific to these types of properties, yeah?
It is the main archetypes we're focusing on are the wimpy no fines, the Lang easy form, the metal framed BRE1s, and also the concrete panelized all-it solution. But in fact, the two pilots we've ended up working on, actually taking to site, are both wimpy. One's a wimpy no fines 3-story in Wolverhampton, and it's a wimpy no fines 2-story in Kent. And both were built, across those local authorities and those areas in their sort of tens of thousands. So these pilots are intended to create the archetypal solution that can be then rolled out by the landlords and other landlords with the same archetypes to be more efficient and to have effectively sort of ironed out the challenges of these through these pilots.
Has this work started already? Have you these
Yeah,
pilots?
so the Wolverhampton one, we had the final meeting yesterday. So we did the closeout meeting and the lessons learned report yesterday. And the Snodland one is due to commence. We've had some interesting discussions with the DNO with regards to the sort of the electricity loadings going forward compared to what they were designed and built for. So, there's been a lot of learnings, positive learnings, but all challenges which have stretched out the program as we try and work through these issues. And the DNO's UKPN in Kent's case, have been extremely helpful and have tried to, find the solution. And I think we have found it, but only really this week. And it has meant a sort of change of policy of how they respond to requests for energy efficiency measures on homes, particularly on a looped system, electrical supply system, which I'm not sure if you've come across that in any of your previous discussions, restricts each property to 60 amps. And we're talking about loadings of 80 to 100 potentially per home. So, they would normally reject an application for solar, air source heat pump, battery, inverter, or tank, particularly to a very high sort of specification to manage what Octopus are going to do, which is the zero bills tariff offer, which this is a pilot for. So they do offer a zero bills tariff offer on new build. And this would be a pilot to test whether they can make zero bills tariff work on existing properties. So we've picked 10 which have already had the insulation, the fabric works done through the SHDF Wave 1 program. And the plan is that we can demonstrate that as each of these SHDF fabric first sort of waves complete, that we can add to that property now a building services package that would provide a zero bills tariff in partnership with Octopus. I dare say others will end up offering it as well, but in our case, Octopus and Clarion are working together to demonstrate that the zero bills tariff can be made to work. And that does mean guaranteed zero bills for 5 years with no standing charge by Octopus. So you sign up to them as your energy supplier. But obviously there's some parameters. I think you're restricted to about 20% of your previous sort of energy tariff demand, so use. So, if you go to work and leave all the heating on and all of the doors and windows open, you're likely not to get a zero bills tariff. But if you're sensible, and whether it's a family or just an elderly couple or whatever the circumstances, the plan is to demonstrate that the zero bills tariff can be offered. And obviously for people generally on low income, in not all, but very often in social housing or the risk of fuel poverty, then for landlords, this is obviously extremely attractive way of helping their residents become more financially secure, giving them that and really giving them financial security forever if it can be made to work. So that's really what we're doing on the Kent one. And on the Wolverhampton one, it was a more traditional whole house retrofit. And there we trialing. We're about to start the actual monitoring and the data of infrared heating against air source heat pump against their original gas bills, so gas and electricity bills. So there's lots of sort of data and monitoring to be undertaken now from here on, but the works in Wolverhampton, the physical works have just completed, and they're about to commence in Kent, as I say.
Mm. Russell, tell me all about, well, tell my listeners as well, all about this technology you've got that sits outside someone's home then.
Very similar to with Chris was just saying, we've got looking at a single unit, air source driven, that is for a single property. In terms of architecture, we're more looking at the 1920s, 1930s, 2-3 bedroom, solid wall homes that typically have little space indoors, little space outdoors. So try to package as small as we can for our heating and hot water solution, so that it can be easily retrofitted into those homes. High temperature so that we don't necessarily have to replace radiators. So we can choose to do that at a different time to reduce bills. It's kind of our hardware package. Really.
So when you say high temperature, you're using R290 units, are you?
R290, yeah.
And your thermal storage is outside as well, and we're talking water thermal storage, or you a phase change?
Water thermal storage, yes. We've done the numbers on alternatives for adaptability, for ease. Water thermal stores is winning for us. Lots of insulation, so making sure we don't lose all that heat to the environment is quite important.
And so you've got these units in, and you're monitoring them. Is that
So we've just finished testing at Salford's Energy House yesterday. So that's where we've been testing our first unit. We're about to start installing those into real homes. That's coming later this month, so that we can get some winter testing completed on them.
got you? I think one of the challenges people have had historically with, are you Energy House 1 or 2?
Energy House 1. So the 1920s end of terrace solid brick. 2 up, 2 down.
Right. Okay. So yeah, because I think Energy House 2, obviously they had the 2 homes built inside, didn't they? But their heating transfer coefficient is so low. Obviously, it has an effect on what gets tested there, because we're talking really low HTCs in them homes. But I can't remember what the HTC is of the one in Energy House 1.
The for how we've got it set up. So we've got it set up with double glazing and a little bit of loft insulation, so 100 mil loft insulation. So the SIBC calculation on that is 6.6 kilowatts. We've got a 5 kilowatt heat pump that's been covering a -3 test quite happily. So it's about 4.5, 4.6 kilowatts heat loss that we've been covering with that testing.
Do you use a specific manufacturer for the heat pump, or have you built your own sort of one?
So we're building our own.
Mm.
So from the ground up, we're looking at everything that would make it more useful for a UK home. So the product format changes, all standard technology, all well understood, well developed refrigerant components in there. But yeah, it's our own manufacture of it.
So my more geeky listeners will want to know whose compressor are you using?
Can't tell you that just yet, because we're not a manufacturer yet. So we're at first prototype self refrigeration circuits, So
Yeah,
we're
but you'll
looking
obviously be
for
using
units
them
to go
to,
to manufacture.
you won't be manufacturing your own compressor. Is
No,
where
we
we are.
won't. We'll be buying that in.
Yeah, yeah,
Yeah.
which is what everyone does in the HVAC industry, to be fair.
Yeah.
But um, and Chris, your solution is similar, but you're doing this for multiple homes rather than a unit for one home. Is that right?
Yeah, the idea or the initial target market for it was mid and high rise buildings and something you could put at the bottom of the building, situated outside, that could then provide heat for that building. So Vital Energy have done. They are involved in district heating anyway. We have done things like this on a bespoke basis, but what we were looking to do was say, okay, can we develop a unit which can be really standardized, deployed really quickly, reduces the amount of technical expertise needed at the actual installation place, make it as, I suppose, as plug and play as possible. And then I guess as you look forward, if you're going to build a whole bunch of these units in terms of your procurement, in terms of the design and the build costs, all of those things come down, the more standardized that unit is. In a similar way, we've got an R290 heat pump. We've gone for the higher temperature end. The idea being then on day one, you can deploy it quite quickly somewhere and then use kind of proper analysis, good analysis to say where it is best putting your energy conservation measures. You know, you can start to say, okay, well, I've got my baseline data here, and then I can rerun some models that say if I installed some insulation, you know, the heat load's going to go down by this. This will reduce my cost by this much. You know, what's the payback on that insulation, or what's the payback on installing larger radiators, which allow me to reduce the temperature of my heat pump a bit. So that's the kind of approach that we've gone. We do have a phase change store in there rather than there is the way we looked at it was if you're coming into a building, you've got multiple houses, multiple flats in there. Likely there's going to be some centralized element anyway, so you could install a sensible storage within the building. But we wanted kind of a hydraulic separation between what's going on in the building and what's going on in the unit. So we've got effectively a HRU in the unit, and kind of our side of the HRU, you've got the heat pump and you've got a phase material store, and then the other side of the HRU, you'd have the main going around to all of the different flats within the building, and in that you could include the sensible storage. The benefit of that being if there is an existing system, then some of those can tend to be quite dirty and not very nice, and it just sort of protects you from maybe some old heating system or some corrosion or whatever in the pipeworks there when you're initially installed.
And have you got anything already working that you're monitoring?
Not that it's due to land on site in about a month. We'll then site's already been prepared, so we're going to test it at, although it's not a high rise, we're going to test it at our offices, our head office, because it has similar kind of ultimate loads and similar temperatures to a high rise building, and then also it gives us a lot more flexibility without needing to rely on agreements with customers or anything like that. For the prototype, we can properly stress test it against you know, where we've got actual control of the demand as well as the supply. So it's landing on site. As I said, we're preparing all of the connection works, and it'll drop onto the slab in about a month, and then we'll have about 3 weeks of testing before the end of this financial year at least.
Are you involved with other consortium partners, or is it?
University of Birmingham
Yeah.
are also involved. So we've got a wider collaboration agreement with them, and we've been looking at different, I guess, novel types of thermal storage, and they've got some amazing people who have spent, you know, a decade looking at different types of thermal storage, both phase change and thermochemical and sort of other types of sensible storage. So we've been working with them, and they've had a lot of input into the PCM side, not least deciding what the material should be.
Mm. Chris, what was I going to say? So it's because obviously my listeners will be very aware of Sunamp, and there's another phase change storage company. I always forget who they are. Um, but you're going to be developing your own and using your own PCM.
Yeah, both the heat pump is a vital energy design.
Mm.
The the thermal energy store is a vital energy design, and the phase change material is it's a composite phase change material, and that is a novel design by or novel recipe, if you want to call it that, by the University of Birmingham. So it's all completely done without the use of sort of off the shelf people, other than for things like compressors or heat exchangers, things like that.
Come back to you, Russell. So with your solution, what were the main things, challenges, and problems you were trying to solve for? So I'm assuming one of them is like distress purchase, because obviously that's a big
Yeah.
problem with people with heating systems. We're all most of society is very used to, like, if the boiler breaks down and it needs to be a new one, that can be done very, very quickly. But of course, as we're trying to transition to different technologies, which take longer to install and longer to organise as well, things like Richard's talked about, things like DNO. So this is obviously one of the challenges I'm assuming you were trying to solve, is it, the distress purchase challenge?
Yes, yeah. The way we approached when we started the company is, what is stopping people from buying heat pumps today? They are they're costly to install. So where does that cost come from? Can we cut down that cost? The disruption to a home from a number of different reasons. So whether that's the install time, the retrofit work that needs to be done, whether that's the storage space that no longer exists in that home for hot water cylinder and associated plumbing. So whereabouts can we put that instead? Hence, we ended up with all-in-one box as a solution to try and really cut down that installation time. I think when we started, there was a lot of complaints about acoustics of heat pumps. So that was an area of focus to begin with. I think as over the last few years, I've seen the acoustics improve on heat pumps that have been launched, the more recent ones. So I don't think that's as much of a complaint anymore, but we're targeting a really quiet system where we can. And then, it's aesthetics of it. We don't want it to be a beige box that looks like a 1980s PC. So something that actually fits in with a house and a garden space. And again, the last few years, we've seen those improving massively on just the look of what goes into someone's garden. That's the hardware side of things. We're also looking at the control side of things. So we have, can we integrate it with the home? Can we understand the home? And this kind of goes into the speed of installation piece. If you can have the product can learn the house that it's in and optimize itself for that house, and provide reports to the homeowner that says, if you improve your insulation, if you change the radiators, you get this was what would happen. And reports that would be, and this is what we anticipate your running cost will be for the next week or the next month, just based on weather patterns that are coming. So using that software to basically make it so that it can be installed and someone can walk away and not need to come back and tweak the settings. That's the real aim on that. But it empowers us to do a lot more things with that embedded software.
So will it do like an automatic commissioning process, or will it still need to be commissioned initially?
You'll still need to do the essentials of no leaks, etc. But so setting a weather compensation curve, for example. So a good first guess would be is what we'd be looking for, and then it will correct itself as you go. So there may be some corrective work in the first month that needs to be done, such as if you're installing without changing radiators, etc., you're going to expect to have some things that come out of that you're going to need to change your filters or clean your filters out. And so there may be some early stage corrective work there, but nothing. We're trying to minimize that where we can.
And what about monitoring? Are you going to be monitoring sort of the performance of your unit?
Absolutely. So this is cloud connected. We we will have running data that will be collected on the unit. So that will be everything from the performance, from the heating performance side, but also how long has the pump been running for, things like that, that will give us some predictive maintenance activities that we can do on there.
So, Richard, come back to you. So, you're obviously more of the holistic retrofit piece. Um,
Yeah.
but are there any particular heat pump manufacturers you chat to or are involved in any way with what you do?
Um, Not particularly. The Kent project will be using Dakin, um, a Dakin cylinder and a heat pump. Um, but I think, the main point really about our archetypal solution, and whether the whole house retrofit is undertaken in one go or, in a number of phases, is that we are, we're providing those I acknowledge, and we all know it is a very expensive process. The actual model and make of the heat pump will vary, from one landlord to another, one subcontractor to another. But what we're providing through the sort of archetype-led approach is, the efficiency in design and delivery and cost reduction through scaling up. But it is inevitable that different partners will use different suppliers and different manufacturers, and some will perform better than others. But over time, we want that decision making to be simplified, the outcomes to be more predictable. Different equipment will be trialed, and obviously new models come in, and gradually, there'll be some more workforce training. We hope skilling up. The residents obviously experience varying levels of disruption as well, which is always a really big issue with the whole house retrofit, and we want to reduce that period of time that they're disrupted, and reduce the levels of disruption. We want to, develop better ways of engaging with the residents, and I suppose onboarding them at the very start, training the landlord staff. So all of these activities, um, you know, will make the process faster, less costly, more efficient. And I think all of the landlords will welcome different air source heat pump manufacturers. They will have preferences. Some will prefer Daikin, some will prefer other manufacturers. That can all be incorporated, and new innovations can be brought in. But the overall property types, they all start off fairly similar with the Wimpy, model, or the Lang model, or whatever those models are, the BISF. So, we're not trying to be too prescriptive about the actual detailing. There'll be different windows, different solar, but overall, we will gradually become more and more efficient in that design and delivery, and the works, and particularly, the whole skilling up of the workforce and training, I think, is such an important part of all of this.
It is. Have you got any ideas around that? Because that's a big. So obviously that's what most of my conversations
Yeah,
are about. The have
yeah.
you got any ideas yourself about that
Well,
challenge?
I think if we can become more efficient and effective in that delivery, and landlords will then feel more comfortable about committing to a higher volume of retrofits and whole house retrofits or phases of retrofit, and they're willing to sort of commit to a forward pipeline, because we're now able to meet their sort of a price point cost that they're happy to commit to, and therefore they'll engage with the contractors on a sort of a longer term pipeline, and provide the contractors, and whether it's the supply chain contractors or the main contractors, with some visibility over a number of years. Then those firms will commit to more training. It's the short termism of the construction industry, that has been such a problem, and you can't offer someone an apprenticeship or training if you don't know whether you'll be working in that town or on that project in 1 month, 3 months, 4 months. So it's that sort of continuity the contractors that we work with in Wolverhampton have been in a partnership with Wolverhampton Homes for 14 years, and we saw the benefits of that in the relationships, in the apprentices, the way that the two sides of that relationship, the contractor and the landlord all worked very well together. They all knew each other. They knew exactly who to speak to, where to go. They had this forward pipeline. They've got they've done thousands, and they've got thousands more to go. And we've really seen the benefits of that compared to other projects that I've been involved in London, where they go to tender and they appoint a contractor, and then you spend 6 months all getting to know each other, tend to fall out, and then that's the end of that project, and then they go to someone else. So it's not just about the design and delivery, but it's about the efficiency of the whole contract process, the relationships, and really a reflection of the whole construction industry, to be honest, which has had its ups and downs over the years. And we would like to smooth out some of those ups and downs and provide some continuity to the retrofit sector and the contractors in it and the manufacturers as well, therefore.
Have you got the social housing landlords? Are they aware of? Because obviously, once your project is finished, you've got some really, really useful information for them. Are they aware of you and what you're doing?
Well, that's the next challenge, is the sort of dissemination, as it's called, of the lessons learned and what we've done. And we had one open day at Wolverhampton, and we had various landlords from Birmingham and Manchester came along, and they met. They did the technical inspection. They met the residents. They were able to discuss the benefits of these retrofitted homes with the residents and meet people living in the homes, and talk to the landlord. And then over the next 12 to 24 months, we'll be monitoring remotely all of the data from the installation, the bills compared to what they were before, pre and post occupancy surveys. And then, we do need to provide the evidence now. But yeah, the challenge is, as you rightly say, to make everyone aware that, if you've got a 3-story wimpy, no fines, or a 2-story wimpy, no fines, we've got the solution. And that is really down to us and our partners to share that, and make the most of it. And yeah, to effectively increase that scaling up, because that's what our project is about: scaling up non-trad, interwar, post-war archetypes. So to be a success, we've got to then scale up from the pilots that we'll have completed.
Chris, this awareness thing is also sort of poignant with your project as well. Are the landlords, whoever's owning these sort of bigger high-rise sort of projects, buildings, are they aware of you guys and what you're currently working on, or are you going to have a separate dissemination piece at the end?
No, they are aware. There's discussions going on with some landlords. Wheatley Group, for example, someone we're talking to. On the other side as well, Vital have a relationship with SGN. So SGN own the rises and laterals in a lot of the high-rise buildings. And these things, as well as you can imagine in a high-rise social housing, you've got the landlord owns the boiler, you've got SGN or another who own the rises and laterals in those buildings, and they get to a point where both of those things need to be replaced, and there's certain replacement budgets for them. And if you said, okay, well, instead of replacing them with gas rise and laterals, you can replace them with water rise and laterals, and instead of a boiler, you can have some kind of heat interface unit, then suddenly that reduces a lot of the cost of insulation. Cost of installation. So yeah, there's already conversations going on with that. Once we've completed the project, being able to kind of prove the how the performance is going to work, demonstrate some of the flexibility that we're looking to demonstrate, then we can start to implement in the high rise. And I think one of the things we're going to do alongside is look at actual modelling. We've invested a lot of time and expertise into improving our modelling. The idea being that you can say have a very good model of a building and how it's going to perform, and then once we've got a very good model of the unit itself and how that's going to perform, you can start to link the two together, and then say, look, this is, once we put this here, this is how we think it's going to perform. This overlaying weather data. And we're looking as well to get complete half-hourly exposure to the grid price, and enable you to do things like at the right size, enter into the balancing mechanism, maybe doing some one-sided frequency response. And it's through those bits, which are kind of the commercial efficiency, you bring in your electricity cost down. So it isn't just about how do we get the most amount of kilowatts of heat per kilowatt of electricity. It's saying how do we get the ultimate cost of the kilowatt of heat to its lowest. And you could do that, for example, even if you had a resistive heater, if you were able to go after the very, very cheapest electricity prices, you might beat the performance of a heat pump, which had to chug along and do 24 hours a day. So we're looking at blending those sort of two things to be able to deliver the lowest heat cost that can then be passed on to the end user.
Russell, you've got a completely kind of different awareness piece, because you're, whereas Richard and Chris are sort of more sort of these social housing type things. You're actual homeowners, aren't you?
Yeah, the target is not necessarily owner occupiers, but it could be social landlords as well. But with not high rises. It's for terraced semi-detached homes. It's the focus. But it sounds like we've got a very similar thermal model to Chris and Vital, that it's looking at what is in that home and how do we adapt to it. I think it's an essential thing that every heating manufacturer should have as part of their product. And it's the sensible future there.
So obviously, as more people start to become aware of this technology that they can use to heat their homes, it's a very competitive market out there. We've got lots of manufacturers. So now obviously your solution's a little bit different. You've got this outside package. It's like you say, it's the thermal storage as well as the heat pump itself. And so have you started to think already about how you're going to disseminate that to these people? Because obviously out there in society, people are getting bombarded with information at the moment. Where do they find information from, and who can they trust? Because there's misinformation and disinformation and all this kind of thing. So have you started to think about your dissemination piece, how you're going to get it across to people that you've got a viable technology they could think about?
Yeah, we're thinking about that. It's certainly, who does it need to get across to? I think there's everything from a general public awareness of heat pumps and that there aren't as many barriers as maybe is put out there, to so the end users in how that product works as well. So once they've got it in their home, how do we educate them to use it once it's there? That's an important area we're looking at. But then, people who are the decision makers on what heating system goes into people's homes, which tends to be
The engineer.
it can be, let's put it, generally the engineer. Yeah. It's the person that's there maintaining the existing heating system. They've got the relationship with the homeowner. They're the people that we need to give awareness of how a heat pump can perform well.
Have you approached any engineers yet? Because like you said, that they're a really important cohort for you, because if they're aware of this technology, then it's a solution that they can offer their customers, isn't it? Have you started to approach? Is that a piece that you've been working
We have, only from a make sure we've designed it in a good way.
Right.
So taking on board some design direction, so a bit of co-design there from both engineers, from some users we've been interviewing via a piece we've been working with the Energy Catapult on, some installers there, and some energy companies as well. So looking at what people would want from the product and trying to tailor it to be as best as we can for them.
Sounds super exciting, isn't it? It's like a new little product on the market. I mean, I'm presuming you got patents on some of this technology.
We're patent pending
Yeah.
on some key areas. We've got some others that we're still in progress with, still to be submitted.
What's the most exciting thing for you? I mean, if I was to ask you, like, what's the most exciting thing? Because you're actually developing your own product, as it were, and because a lot of engineers are used to products that are all been around for decades. Some of the HVAC companies have literally been around for decades. I mean, as I often say on my own podcast, heat pump technology has been heating UK buildings way before we had natural gas boilers. So that first methane ship didn't dock at Canvey Island until 1959. The first heat pump system started going in around about 1928. So we've been heating lots of UK buildings. We've got the biggest commercial market in Europe for heating with heat pumps. Um, Obviously, lots of people look up and think, "Oh, that's air conditioning," but they don't realise it's heating them as well. There's like thousands and thousands of buildings that already got this stuff, air to air usually. But you're obviously designing and making something kind of brand new. So are you excited about anything in particular? I mean, if I was to ask that question to other people, they'd probably say the control and how it's controlled because we're all used.
Definitely, that's a big part of it. Yeah.
Yeah.
I think I probably started with when we were looking at what was needed was thermal simulation of the home. So that leads into how well can it be controlled for a particular home, and I think a few people would go down the how can it be more efficient, but really it's how can it be the most cost effective for that home. I think when you speak to typical end users, they don't really care too much about absolute efficiency. They perhaps don't necessarily care about that they're transitioning to a not burning gas and that they're not producing as much CO2. What they care about is does it reduce my bills? And so that's probably where we get to on a lot of that control side of things. But there's a lot of exciting things that we're doing in just the packaging of the product. That's my background's airflow, so that side of things, the aerothermal design is quite exciting for me.
Oh, that is exciting. So are you going to be developing a new fan that pulls in greater
We're not
quantity
we're
of air?
not a new fan. Just we're using off the shelf, but to try and make it as quiet as possible. That's where the airflow packaging comes in.
Well, I suppose the advantage you've got is because you kind of got an acoustic enclosure already, haven't you? Because you're designing this thing to be a standalone thing that goes in someone's home outside, and of course you've got the benefit then of being able to play around with sort of different acoustic enclosure type. Um,
We are absolutely, yeah.
mm,
For the key components, we've got a fan, we've got a compressor, and we've got pumps that are all potential to be an annoyance to people. So we're looking at how we can hide it away as best we can.
and so that's going to be, I imagine, one of your USPs for your particular product. Then is it the quietness?
It's target, definitely, yes.
Mm.
I'm not going to say we're going to achieve that target, but to be a loose target that I have is to try and be the quietest air source heat pump on the market. We'll see how we get on with that. Um,
That's interesting.
but we're in progress.
That's interesting. I'll come and test it for. So I don't know if you know much. So my family has been involved with acoustic sensitive installations for about 4 to 5 decades. So we do radio stations, TV stations, recording studios. Because obviously in them places you can't have a heat pump system that's noisy or emitting certain frequencies. So obviously some frequencies the human ear can't pick up. But yeah, we have to test all our systems because obviously when you record it. So we've just recently replaced. We did Dave Gilmour, Pink Floyd's studio back in 1986. So we've just replaced the system for the new studio, the studio owners. And of course, then we have to test it, and acoustic architects will also come in and do their tests as well because no one wants a recording studio where you're picking up unwanted frequencies. But I think the noise thing will be interesting because I still hear, that's one of the big concerns of um, people that may be thinking about having this in their own home is this noise thing. Um, Lots of people have been trying to, they call it a myth, and it kind of is one of the things. Perhaps we don't have to worry about so much, but these things can be noisy. Trust me. That's why they can be noisy. I mean, there's millions of fan coils out there in our society, which probably people don't realise. But yeah, some of them can get not quite noisy. So I think you've got quite a unique USP then. I suppose, Chris, similar with you, because yours is this outside packaged unit, you're going to be able to play around with sort of acoustics.
Yeah, we spent a lot more time and effort on that than I was expecting to do. I think part of the issue discussion that we've had is because we've got this an enclosed unit, and because it's quite a bit bigger, it's been whole things around the ATEX requirements. So even though the unit isn't going to be one which anyone steps in, you've got kind of open doors. They're only reaching to get into the heat pump. We got told that the heat pump's actually in the enclosure, so all of the equipment in there's ATEX Zone 2 rated, and we've also got to have a constant ventilation on there in the case of a leak. So then, obviously, there's a route out for noise via that ventilation. So we had to do some significant designs on that side of things. But yeah, the enclosure, particularly around the main gubbins of the heat pump and the ventilation, there was a lot of thought into that. We also got low speed, low noise fans. We set ourselves quite what felt like an ambitious target for the noise. Obviously, compared to, I think your point about the noise is valid. So if I want to install a heat pump from a planning point of view, I have to consider, the noise of my next door neighbour is going to experience. But it's perfectly okay for me to just plonk it outside my own window or door, and there's no real consideration to how much noise I am going to be impacted by it. So I think it is an important consideration. There's also sort of urban noise creep of having, lots and lots of these things added together. So we really, really wanted to focus on keeping the noise as low as possible. So yeah, it was a key part of the initial outlook of it, and it's been a key part of the design as we've gone through.
Russell, how much do your things weigh? Because obviously we've got to move these into people's usually back gardens. It doesn't have to be a back garden, but have you got like a strategy for how that? Because it's obviously going to be a heavier than what these what people are used to with their monoblocks. This is your solution is going to be heavier. And have you sort of thought about how they get sited?
Yes, a lot of thought into that. We need to make it lighter. From our prototypes at the moment, that's a definite from our last couple of weeks worth of installing in Salford and uninstalling. The Essentially we're looking at how can we make it in modules that we can break apart and then simply assemble on site. So that it gives. So if we look at a typical challenge that we might have is a terraced home where we've got to be able to take the product up the steps to the home, through the home, and site it in the back garden. That's our challenge. So it needs to be a team of two need to be able to do that day in, day out without it being too heavy, with being able to fit through doorways, etc., with being able to maneuver it around. So that's been criteria from day one, being able to do that. At the moment, it's too heavy though. So we're trying to look at how we can make things lighter.
Now, I imagine that's one of your biggest challenges, then, isn't it? This whole to try and make it modular so that it all fits together nicely at the other end of the property.
Yes, yeah, and goes together flush and needs. Yep, that's we're getting there with that. We've got another little round of prototypes to do, which we hope to fix a lot of the bugs that we've got in that at the moment.
Because obviously, when you have things that are modular, the other challenge is make sure the engineer knows how to put it all back together properly as well and sufficiently, because that could be disastrous if they don't. And Chris, I don't suppose that's too much of a problem with your, because you're more commercial, aren't you? So it's not really a thing.
Yeah, the idea was that we did as much prefabrication as possible on site. It was we looked at different transport methods, so that influenced the dimensions of the design. Like, okay, can we fit it on the back? Initially, we wanted to fit it on the back of an 18-ton truck with a high ab, but quickly realised that actually, whilst dimension-wise we were okay, weight-wise we were going to be above that. So effectively, it's just going on the back of a HGV. Send one of these units, pick it up, ready to go from the factory, deliver it to the site, and then you can just, it has the interface points for the water and for the power, and then away you go.
Richard, these properties that you're, these particular archetypes that you're working with, do they have, or are they known for having sort of damp and mold issues?
I think, Yeah, certainly some are, some do. Um, and I think one of the points really probably that I didn't make earlier, Nathan, is that very often, the works that we're doing as part of the retrofit are combined with other remedial works and other works to the property that, might be part of the landlord's plan maintenance regime, which helps to sort of make costs more efficient if you're and also less disruptive to the residents. So the three-story Wimpys, for example, they didn't have damp and mold, but they had a garage on the ground floor that was far too small for anything other than a mini built, in the 1960s, 50s to get in. So we converted all of the garages to living space. So all of the residents got an additional room. The garages were taken out. Obviously, they lost storage space because most of us fill our garages with all the stuff from Granny's attic. But so the residents get uh, other planned and reactive maintenance works undertaken at the same time as the teams in there. And it might be rewiring, it might be re-roofing if we're putting on solar and, the roof's not been replaced for 25, 30 years, then we would do the roof at the same time. We did have mold and damp on one property in the London Borough of Sutton, and they'd suffered this chronic damp for about 15 years, to unhealthy levels. And it actually turned out there's a pipe that was leaking under the property and had caused no end of trouble. So, some that should have been repaired long before we got there. So I think when we do get there, we're doing all these other works, and it might include the insulation, re-roofing, conversion of the garage space, new windows and doors. If there is mold and damp or other issues that need to be addressed, they would always be addressed at the same time. So it is an opportunity to undertake any of those other maintenance activities. But generally, they're solid wall properties, and they mostly perform reasonably well in terms of damp and condensation until we started putting the wrong insulation on the outside in the sort of 70s and 80s, probably. And we're removing most of that now. We're certainly removing cavity wall insulation now when we do this work. So, so we're also remedying a lot of the errors of the past at the same time. And a lot of them are the cause of that damp and mold and damp. So, and obviously ventilation goes in. Sometimes it's doing, MVHR, and sometimes it's more extract fans and trickle vents only. So there's a whole range of different solutions. But the plan is that we leave those properties as warm, comfortable, healthy homes for the next 40 years. So we're giving them a 40-year life extension, when we finish this work. So it is expensive, but you're getting another 40 years out of a house or a flat that was built originally for 40 years, 60, 70 years ago. So you can't avoid the fact that, there is inevitable expense in keeping these properties going for another 30, 40, 50 years.
You mentioned earlier that you're looking at sort of kind of different technologies. I think you mentioned infrared.
Yes, that's right.
I mean, are you looking at different heat pump technologies? So obviously there's air to air as a solution for some of these buildings, and there's obviously solid state. I don't even know where there's solid state heat pumps now that also ventilate the property as well.
Right. Yeah. Well, I think I haven't been, Nathan, to be honest. And some of the other teams in this whole heat pump ready program, may well cross over and integrate with the type of activities that we're all doing. And I think, as the heat pump ready project comes to an end, there may be more of that interaction between different technologies, different innovations. People like Russell and Chris, working with us or others, and looking at those new technologies. But the infrared trial, it's a relatively small company called Ambient. It's a new manufacturer, and they've got the opportunity to trial their infrared solution. Wolverhampton Homes are interested in seeing if it works and how much particularly it costs to run.
Mm.
So there's lots of different sort of elements to the sort of research. We've got Mixergy providing, some of their equipment, a relatively new small manufacturer. So I think this whole process does allow other manufacturers, other innovations to integrate, with our broader sort of service and project management delivery whole house solutions. So as new ideas come along, innovations, we'll try and incorporate them into what we're doing.
And this sort of archetype-led approach, can you see yourselves in the future maybe picking, choosing another archetype and sort of doing a similar thing for that?
Yeah, completely. I
Mm.
mean, that is exactly the plan. So we're doing 4 now, um, and there's probably 5, 6, 7 which are, the most common in that sort of post-war period. So I think the government picked about 30 or 40 um, different, modern manufacturers, as they were called then, off-site or factory produced. But they were mostly either timber, steel, in situ concrete or panelized concrete solutions. And as the years went by, a lot of them dropped by the wayside, and maybe just fewer than 10 became the most common, the most common archetypes that all local authorities were buying at the time. And the big contractors like Lang and Wimpey were far more efficient at it, and I think really took control of the market over a period of time. But there's a lot of the area houses, you've heard of the area house. So there are, and we are developing those archetypal solutions. But this particular program is just about picking 4, the Heat Pump Ready program, and working through the full solution, design solution, all the heat demands, all the options for 4 archetypes in particular.
Mm. Yeah, it's an interesting approach. I like it. Russell, what if I was to ask you, what's the main takeaway you've learned from being involved with the Heat Pump Ready um, project? I'm going to probably ask you all that as well. Is there something that sort of really surprised you, or is there something, a main takeaway? Because like I say, it's finishing soon, and well, there's obviously some wave 2 stuff going on, I think still. I think you're all wave 1, aren't you?
No,
Yeah,
we were wave 2.
you're wave 2, are you?
We've been going about 10 months, I think, since we kicked off.
Yeah. So if I come to is anything you sort of really sort of pinged out as something you've learned from the project?
Me. I think what I've learned is what I didn't expect to learn was from the piece of work with other companies, like the 2 gentlemen here, that it's a very similar problems going on in different areas. And I think one of the problems that I still think exists, which is a barrier, is understanding the heat loss for home before products goes in. I think that I hear more so that getting that right for heat pumps is I know it's the important part of heat pumps, but I hear more that actually it's a hard thing to do up front. So that's probably the area for further work for me. But yeah, it's been really educational hearing from all the other companies that are within the program and the challenges they have.
Yeah, it's a very interesting piece, that the whole thing of like knowing what a home actually needs, because obviously most engineers are going to be using some sort of calculation tool, and as good as some of them calculation tools are getting, there's still assumptions. You're still having to make assumptions. So the whole U value system really is an assumption. The way we get our U values, and then obviously we've got actual measurement. So you've got companies that are doing actual measurement, aren't they? But there's challenges there with some of that technology as well. So it's quite it's a bit of a hard challenge to solve at the moment and of course engineers are getting you know, because as gas engineers transition, for instance, they're starting to become more aware of this whole thing called heat loss, because a lot of them aren't aware of it at the moment. Bless them. Um, so they're obviously now getting messages that they're going to have to be at some point doing this kind of thing. And of course, you can get errors. Lots of people are finding that they can get errors when they do a heat loss calculation. So that's an interesting aspect of the whole piece. I mean, have you got any ideas about? Do you think it should be measurement, or do you think there's some ways we should measure it differently, or are you quite
Personally, I
happy?
think it should be measurements.
Yeah.
Once we put our product in, we'll be able to assess the home.
Mm,
But without the product in, then you need to know it beforehand. So make sure you get the right size product. Put in too large a heat pump, you end up with problems of short cycling in warmer weather. So we don't want that to be happening. There's potential ways around having a smaller size heat pump and some other um, more direct heating,
mm.
which might help balance things out. But yeah, each property is different. Whether you get your prediction of the heat loss correct up front um, will affect how the product works.
Mm. Are you going to have quite a wide variety of size ranges, or are you going to just stick to sort of like two or three?
Two at the
Yeah,
moment.
yeah,
Yeah.
yeah, yeah, yeah. And I suppose, Chris, with your solution, I mean, you kind of got more scope to have um, whatever size you want, I suppose, in some ways.
Yeah, we did a lot of work actually before this project as part of another government funded project where we looked at what the optimal sizing was, because we came from the angle of this approach of we're under heat as a service, doing it from a big centralized energy center connected to, I don't know, 1,000 houses or whatever is problematic in terms of deployment. So we said, okay, well, where's the sweet spot that we want to hit? In theory, we could electrically connect up and run a load of heat pumps in people's homes and sell heat as a service that way. But we looked at, okay, where was the sweet, or I guess the lowest point at where you can get a lot of the efficiency benefits of. So an individual, I guess people are changing all the time, but an individual heat pump in someone's home, you might only have one heat exchanger, whereas we can look at having one for taking out the superheat, one for taking out the latent phase. Then you can look at subcooling. You can look at having, finding the best compressor and what the sweet spot is in terms of compressor efficiency. So we did a lot of work in that to say, okay, what we wanted to go for was the 100 kilowatt thermal heat pump, and then we could modularize that. So just stick another one of these containers next door to the other one if you had more properties. Or the idea again is for them to be distributed, so you would have them, dotted around the place rather than taking up a huge amount of space. So that's the target that we've gone for. But yeah, it is flexible. We could evolve in the future. As I said, you could include different types of storage in there. If the storage changes in the future, we could include it to be a water source instead of an air source, in case there was possibilities to do boreholes or something like that in the area. So there is some flexibility there, but we don't want to have. The idea is to have not too many versions of it, because then that starts to reduce down some of these benefits from standardization. So sort of finding that balance.
Russ, where are you guys based for
We're based in Bristol.
your Bristol as well? Yeah. I might have to come and visit you guys and see what you're
You're
up to.
welcome to come visit anytime.
Well, it's been great to speak with you all. I really enjoyed the conversation. I'm sure my listeners have also, and wish you all more success in your future projects. Thank you for coming on the show.
Thank
Appreciate
you.
it. Nice to meet you, Nathan.